Hi there, I want to talk about bonding today, and three types of bonding are ionic, covalent and metallic bonding. And bonding is just simply when elements combine together to form compounds. So I've just said there's three types of bonding: ionic, covalent and metallic. Ionic compounds are formed when metals combine with non-metals. So if I took elements found in groups 1 and 2 and 3, metals, they combine with the elements found in the non-metal groups, such as groups 6, 7, 8 and O. Covalent compounds are formed when non-metal elements combine together to form compounds. Metallic bonds are formed inside metals when metal atoms combine together. Simple example: sodium reacts with chlorine to form sodium chloride. Carbon can be made to react with hydrogen to form methane, an alkane gas obtained from fractional distillation of black gold Texas tea oil. And metallic bonding is found in copper. Other examples: magnesium oxide, calcium chloride. Covalent: hydrogen gas, water, the wet stuff, nickel, sodium, etc. So if something contains just non-metals, it's a covalent bond. If it contains metal and a chloride or non-metal, it's an ionic bond. And if it is a metal, it just contains metal atoms. Let's look at a simple example: the bonding in sodium chloride. Sodium chloride. Sodium atom has got a configuration of 281. Chlorine has got an electronic configuration of 287. Let's draw them out. That is sodium. These are sometimes called dot and cross diagrams. And then you got chlorine, 287. There's the nucleus, there's the nucleus. Let me change my pens. 281, 1, 2, 8, 1, 2, 3, 4, 5, 6, 7, 8, and 1 electron in the outer shell. Chlorine, 2, 8, that means that, go and count, 3, 4, 5, 6, 7, 8. The outer shell of chlorine, 2, 1, 2, 3, 4, 5, 6, 7. When they combine together, sodium donates an electron to chlorine, and this structure then changes to 2, 8. That outer shell is full and therefore it's stable. The outer shell of chlorine changes from 287 to 288 and is therefore full, and it's stable. So ionic bonds are formed when metals donate electrons to a non-metal. Let's look at covalent bonds. Co means sharing. Covalent bonds like I said before, are formed between non-metals combining with non-metals. Hydrogen, a molecule, H2, oxygen, O2. And is formed by the sharing of two or more electrons. If I took a simple example, hydrogen, H2, it's a diatomic molecule. It consists of two atoms of hydrogen. Hydrogen's a little boy. Let's look at him. There's the nucleus. Contains one electron in the outer shell. There's another one electron. So what happens is, when an atom of hydrogen combines with that of a second atom of hydrogen, they share those electrons. Let me do another diagram of that. Dot and cross one. There we are. There's the nucleus of hydrogen, There's the outer electron from that atom. There's the outer electron from that atom. So that is a covalent bond, meaning that a pair of electrons are shared. Let's look at another example when I look at methane. CH4, I'm just going to draw it like that. That's a bond, that's a bond, that's a bond, that's a bond. Carbon is found in group 4 because it's got 4 electrons in the outer shell. Carbon is a nucleus, 2, 4, 1, 2, 1, 2, 3, 4. 4 electrons in the outer shell. Its structure is therefore 2, 4. Here is hydrogen next. There's a nucleus. Its structure is basically just 1. So therefore what happens is, when carbon combines with hydrogen to form methane, CH4, there must be electrons being shared, and that is what the diagram would look like. And there is 1, there is 2, hello, I can't count, there is 3, and there is 4, and there's hydrogen, the little boy, there's hydrogen, the little boy. What happens is they share 4 pairs of electrons. So, sharing of electrons, covalent bonding. Oxygen, O2, there is O, there is O. Its structure is 2, 6, 2, 6, 2, 6, 2, 6, 1, 2, 1, 2, and it's got 6 electrons in the outer shell because it's found in group 6, and in the case of oxygen you've got 2 pairs of electrons shared, and in nitrogen, N2, you have 3 pairs of electrons sharing, which means oxygen and oxygen, how does it? It's got a double bond, and if I took nitrogen, it's got a triple bond. And the final type of bonding I want to talk about is metals. Copper, nickel, lithium, sodium, potassium, rubidium, aluminium, they're all metals. And this is what happens when the atoms combine. They have electrons in their outer shell. They lose an electron, or they could be 2 electrons if it's group 2, group 3, aluminium, it could be 3. They form ions, metallic ions. So if I looked inside something like sodium again, it forms, when they combine together, these atoms, that's sodium, that is sodium, that is sodium. When I look inside a metal element, it consists of ions, positive cations, and Na plus, Na plus, Na plus, Na plus. It could be copper, anything else, sodium ions, and between those sodium ions there's electrons which are free to move. And in copper it would be the same. There's free electrons inside that metal. Nickel, there's free electrons inside nickel. There's free electrons inside the copper metal, and therefore that explains why metals conduct two things: electricity and heat. I'll be talking more about the internal structure of metals in a later module. Recapping, ionic bonds form between metals and non-metals. Covalent bonds form between non-metals and non-metals, and metallic bonding is what's found in metals.